Whenever you're ready. Can
Can you
everybody
just
hear
do
me?
some like practice problems with the problems that were in the video for 7 or for Friday, I mean. Sorry.
More practice problems?
Yeah, I feel like more practice is better.
Okay, let me pull up, let me stop this sharing and go to a screen share. And let me go to Canvas, and we could pull up one of those. There's actually 3 sets of practice problems, so there's tons and tons
Okay.
that are there. So let me see. Let's, and some of them have a lot of different have some protection and stuff. Any of those look interesting?
Maybe C.
Okay, so C, we're gonna make a ortho. Let's say we wanted to do that. Let's say we want to do C here by, let's say we want to do it by protection, because it's ortho, and we would expect, because these are sterically next to each other, they're kind of sterically hindered, we might have to use protection on that. I will tell you when, we need, when you need to use protection, but we could do it either way. So we want to take benzene, and we want to convert it to, we want this carboxylic acid group here, and we want the Br group there. So, and let's say we wanted to do this by protection. If we're looking at this, we have our orthopara director. We know how to put the bromine on the ring. That's just going to be, we're just going to use Br2 and either Fe or aluminum Br3. That'll put the bromine on. To put the carboxylic acid group on, we've got a couple of different methods. Probably the easiest way to do that is to put an R group on and then convert it to the carboxylic acid with KMNO4. So the idea is, first we should figure out how to add our groups, and then we can figure out about the sequencing. You could put a bromine on here. We could end up with a bromine. Here and then make a Grignard out of it, but the problem's going to be that we can't have one bromine here and another bromine here and try and make one of those two the Grignard without potentially making both of them the Grignard. So this would probably be the easiest way to do that. And if we want to do it with protection, then we're going to block either position to the bromine or the para position to the carboxylic acid. So which group do you want to add first? The alkyl group or the bromine?
Bromine.
We can add the bromine first.
Okay. So if we add the bromine first, let's put the bromine in, let's put it in the same position that it's going to end up with. So let's just put it here. Okay. Now, if I'm going to add the methyl group, or if I'm going to add an alkyl group, the major product is going to be para, although you could say I want, I just want the ortho product. So let's go ahead and protect this and say, okay, I want to protect the para position by using the SO3 H2SO4 to then put the sulfonic acid group in the para position. And the bromine is still going to be the director here, because it's next, it's the highest on the electron, or it's the least electron withdrawing group. This, according to that one chart, is probably, this group is probably equivalent to a carbonyl. So since the bromine is higher up on the chart than the carbonyl, this will do the direction. So then we could go ahead and add any alkyl group, or you can just say RCl. I don't know, for the sake of argument, I usually just like to use a methyl group. So the methyl group is going to be directed by the bromine to the ortho and para position, but of course we blocked the para position. So that's going to force the methyl group to be placed. So then it's blocked. So now what we'd want to do is convert the methyl group to a carboxylic acid with KMNO4. That's going to make the carboxylic acid group. I'm still protected down here. And then to remove the SO3H group, we just use steam. So this might be a reaction where I would ask you, I would say, take benzene and convert the benzene to the to this molecule and use protection to get the highest yield possible. Protection always means, I'm sorry, it's not protection. I'm getting confused here with, I'm getting confused with the new lecture stuff, with blocking. So use the blocking strategy to make the groups become ortho.
Okay, that makes sense. Thank you.
So I mean, the steps are going to be, first you got to figure out how to get the group on the ring. And then if you have groups like, for instance, if you're going to put an R group on the ring, that means that if you want the other groups to go ortho-para, you need to put those groups on before you convert it over to the carboxylic acid. On the other hand, if you want the groups to go meta, then you can convert the R group to the carboxylic acid and then put them on. So once you have the series of reactions, it's just a question of getting the sequencing right.
Can we do another one of those reactions, but with one of the side chains being one of the like OR groups?
Yeah. Let me go to my screen and let's see what we've got. Oh, there's no OR groups there. We could make F an OR group,
Okay.
something like that. I mean,
Mm-hmm.
we can make these problems up all day. The problem is making sure that they have an answer, which isn't always. Sometimes, you know, the difference between 2 or 3 steps and 20 steps is one group. So let's say we wanted to add an OCH2 CH3 group here, and let's say we wanted to add our nitro group here. And I don't know. Let's say we wanted to do, let's put a bromine here. Again, I might have just made it more complicated than it needs to be, but so we know how to add the bromine. We know how to add the nitro group. We just need to know how to add the OR group, and that's where that chart, let me see here. So in the Fridays in the March 20th folder, there's that list of aromatic reactions. That's where that's going to be really helpful in terms of going through this list and saying, okay, I need to add an OR group. Where is my, you know, how do I add my OR group? And we keep going. And first we need an OH group on the ring. So we'll need to follow these steps. And then to put the OR group on there, once I get the OH, I'm going to have to deprotonate it and then do a Williamson ether synthesis with a primary or secondary halide. So that's where this is going to be useful. And I mean, for Friday, you know, for the exam I put up on Friday, you're going to have access to that. So you need to know how to use it. So if we go back to that problem then, and at some point, if something doesn't make sense, you know, go ahead and jump in and yell. So we're going to need to, first of all, put our OH group on the ring, and then we're going to need to convert that to an O minus, and then we're going to need to react that with, since I'm putting an ethyl group on the ring, I need to react it with ethyl chloride. And since all of these are meta, I don't want to add the bromine. I don't want to add the bromine because the bromine will, don't want to add the bromine first because the bromine's going to direct ortho and para. So the bromine's going to have to go on last. And the nitro group could go on first. That's fine. Although, as we go through this, we'll see that we want to be careful when we add the nitro group. So let's work on the OH group first. So let's take my benzene and without reagents, let's just think about putting groups on. So first thing I'd want to do is put a nitro group on the ring. Then the next thing I want to do is convert the nitro group to the NH2 group. And notice I'm not adding the second nitro group because first of all, if I added the second nitro group over here, I'd have 2 nitro groups. So then I'd make 2 diazonium salts, which is not what I want. So I'm going to convert it to the NH2, and then I'm going to convert the NH2 into my diazonium. Now, because the diazonium looks like an X multiply bonded to a Y group, it's going to be an ortho director. So I might say then, you know what, let's go ahead and let's put the nitro group on the ring. And at this point, I should probably put the bromine on the ring too, because it's it needs to go into the meta position as well. Because once I turn the N triple bond N into an OH group, it's going to direct ortho and para, and so I need to get the bromine on while I have this group that's directing, and the nitro group would also direct to the meta position. Is everybody kind of okay with that?
Yeah, thank you.
So then I would want to now finally convert after I have all my groups in the meta position, I would then want to convert that to the OH group. Then take my phenol and convert it to the phenoxide group. In other words, deprotonate it. And then finally react that with the ethyl chloride to do the Williamson. To do a Williamson SN2 reaction to then give me the final product. So sometimes it's useful to kind of plan this out. And then once you have it planned out, then go back and put in the different reagents. So then you would go back in and you would say, okay, I'm going to use nitric and sulfuric acid for the first step, Fe, tin, or tin, HCl for the second step, NaNO2, HCl for the third, another nitric acid, sulfuric acid, the H3O plus. You could go ahead and just use hydroxide for that step, and so then you could go, whoop, one more. What did I do? Oh, I needed Br2 here and FeBr3. So you could go in and put the reagents in after you've got the sort of scheme written. And there's usually more than one way to accomplish this. So as long as all your steps are correct and your steps are going to give you the product that you're putting down, you would get full credit.
Okay, thank you.
Might be able to give you one and put you all in a chat room and have you work together on it.
That sounds fun.
We haven't tried, or I could break you up. How many of you are there? 5. Or I could break you up into 2 groups, or I could just let you all go at it at once. I haven't tried that. That's an advanced option. Let's let me first, let's save this screen and let's go to my screen and come on. Let's see what's here. How about something like B? Let me put that on the whiteboard. So I'll give you a minute, and I don't know what the chat rooms do, but we're all in one big chat room now. So how would you go about that one?
You want us to just answer?
Well, I'll give you a minute, and you can think about how you do it, and then you can help. Then we'll write out the synthesis, and you can give me what you would do. What do you want to do? Somebody can give me whatever their first or whatever step down the road.
I said for the first step to use the reagent ClC double bond O CH2 CH2 CH3 with AlCl3.
Okay, so that will that'll be Friedel-Crafts acylation, which will put the carbonyl group on the ring.
And then I added the Cl2 FeCl3 to, and then I put the Cl on the meta position.
Okay. And we have to do that now because we have to put the chlorine on now because once we change the ketone here into the alkyl group, it'll be orthopara. So we want the chlorine to go meta, so we have no choice but to put the chlorine on now. Okay, I'd buy that.
And then I used the Wolff-Kishner reduction, the N2H4KOH in heat.
I mean, that seems like a reasonable way of doing it. There are probably other ways to add this alkyl group, but they would involve using some of the, you could also put this group, you could also put the alkyl group on using a Gilman reagent. You could put it on with probably a Suzuki coupling as well. But the problem is once you put the alkyl group, any alkyl group, it's going to direct the chlorine, ortho, and para. So this is the, well, probably the only method we know to put an alkyl group on the ring, but have it be ortho directed as in the process of putting it on.
How would you know when to use the like Suzuki or Heck coupling over any of the other methods?
Well, let's let me I mean, they're kind of optional, but one of the things I would say is, like, let's one of the problems. Let me share my screen. Let's say that we were looking, because there's quite a collection of molecules here, and some of these are going to sort of try the, well, this one, making a benzene ring from a benzene ring is pretty easy. But like for A, putting a CH double bonded to a CH2 on the ring along with an OCH3, that might be a little challenging. So let's say we wanted to do that, and we want to take our benzene and we want to add like a CH double bonded to a CH2. And then down here we wanted our, well, actually, we could put it meta and say we wanted to put the OCH3 group there. So if you think about the meta substitution, putting this group on the ring, that's always going to be, that looks like either an R group or it looks like a benzene ring group with a double bond. So that group is going to be an ortho-para director. So we don't necessarily want to put this group on and then add the O, but we know if we want the OR group that at some point we're going to have either the NO2 or the N triple bond N that will be meta directors. So in the process of putting this group on, of putting the OCH3 group on, in the process of putting that group on, we'll be able to add a group meta to it. But if you think about if we thought about, well, how many different ways do I have to add the double bond to the benzene ring directly? This might be a case of, okay, let's say that I wanted to use ethylene with palladium, I think it's palladium acetate, and triphenylphosphine. So in other words, we could do Heck coupling to put that double group bonded group directly on the ring. You could say, well, I want to put do Suzuki coupling on that. So the only question with that would be palladium and carbon and potassium carbonate. So that would be Suzuki coupling. The only question would be, how would you make that borate? And that borate would come about from taking the triple bond and adding to it the borate ester. So you could add that group by Suzuki coupling. And right now I'm just thinking of all the different ways that we know to add this CH double bond CH2. You could also say, you know, once I get that, I'll just go ahead and add my ethyl group. And then I'll go ahead and convert that to the I'll brominate it at the benzylic position. And then How about I just do a simple E2 reaction? To give me the double bond. That would work if you didn't want to go that route. You could be more creative. And say I'm going to add the carbonyl. I'm going to add this by Friedel-Crafts acylation. I'm going to reduce that carbonyl down to the alcohol. And then use H2SO4 and heat to do a dehydration. Now, you wouldn't have to show all of those methods. You just have to choose one. But the idea is that while these ones take multiple steps, you could, in theory, just use HEC and put it on in one step.
Okay.
So, I mean, there's lots of ways. There's usually more than one way to do each of the problems. The critical thing is you have to make sure that all of your steps are legit, meaning that the reagents that you're using are actually going to do the reaction you proposed, and that if you're going to put groups on the ring, they have to go where you want them to go. Like if you have an ortho-para director, you need to put ortho and para. And I guess for, you know, Friday or for the exam, I could both draw up a scheme and ask you to provide the reagents, which I probably will do. And each one of those is its own problem. And then I'll ask you to come up with a scheme like you did for today's quiz, which I'll go through and start grading here this morning. So when the grades show up, you can go in and take a look at it.
So with the Suzuki one, we don't have to show the triple bond with the reacting with the H with the boron.
No, well, I usually give you free rein to use what you want.
Okay.
But because this step is so integral in forming that reagent, I might ask you to do this. I might ask you what the product of this reaction would be, and then maybe ask you to react that product with the benzene ring. There may be a problem like that.
Okay.
So remember that for this one, we're adding the H and the boron, 100% cis, with the boron going to the least hindered carbon. In this case, it would be, it doesn't matter which carbon it goes to. These can get really complicated really fast.
Why is the diazonium salt created or as like an intermediate between adding a lot of the reagents? Is it just to be like a meta director, or is it like I feel
Yep.
like in the packet there's like a lot of like forming diazonium salts?
Because the diazonium salt is in the reactions that we're learning the reactions hopefully we've learned, or the diazonium salt lets you go a number of ways. So you could take the diazonium salt and you could add a copper halide to it and end up adding a bromine or a chlorine to the ring. So once you have the diazonium salt, you can react it with copper chloride or bromide. So that would be X equals Br or Cl. You could react it with copper cyanide, which is our only way that we have to add a C triple bond N group to the ring. We can react the diazonium salt with H3O plus, because that would then let us add the OH group. You know, we could add sodium iodide or potassium iodide and add an iodide to the ring. There's a lot of drugs like let's see, it's HBF4, I believe, that there's a lot of drugs that have fluorines on the benzene ring, and so that's a convenient method to add a fluorine. So the idea is from the diazonium salt, we have all these different reactions that allow us to put all these different groups on the ring. So it's what would be called an intermediate compound, because it would let us make all these different compounds from it. So when in my PowerPoint notes, I had these all as separate reactions. I do have a version of that where I wrote them out as kind of this wheel, where once you have that, you can go in all these different ways. So it's important from the standpoint of all the different compounds that I can make. And for some of these, like fluorine or OH or C triple bond N, that's the only way we have to add those groups. I guess iodine too. That's the only. We can put halogens on with bromine and chlorine, but the other ones, that's the only way that we have to add those groups.
Okay.
So that's why the diazoniums are important, and I wish every book just moved it out of the amines chapter into the aromatic chapter, because that's where we end up using it and talking about it the most. But that section is actually in chapter 23 for some reason. But that's the importance of it, is because I can do all of this. And I if you look at some of the older exams, you'll see that I usually ask the reagents that I'll usually say, well, what reagents, do you use to get to this point? And then I'll have all these different reagents, or I'll have the products and you have to fill in the reagents.
Okay.
So it's just really versatile from the standpoint of putting on these groups, because if we're going to learn the chart of number 1 to number 10, it'd be helpful if we knew how to put each and every one of those groups on there. Is everybody ready to work from home and not be allowed out of your house? Except to do essential functions.
At midnight, right? Is that when it starts?
Yeah, I guess. I don't know. I think I filled out the paperwork so I can go into the building in case to keep the NMR magnet thing. I don't know. This has escalated pretty quickly. Anything else? I mean, I'll be grading the quizzes as people turn them in. So I graded some last night just to figure out how to do it efficiently. And so I'll be putting the scores in. And if you have any questions on those, you can email me or we can schedule a meeting. I also, for the NMR problems that are for lab, if you have me for lab, I have to put up an explanation sheet about one of the problems that's in packet number 4, I believe. So I'm going to do that this morning because there are all sorts of things you need to know about that in order to be able to answer it. So if you've started on those, great. If you haven't, when you get to that problem, you're like, I don't know what to do. There'll be a sort of a helpful hint type thing for that one because it's got a lot of nuance to it. Anything else?
No.
All right, get everything together before the door's shut. I don't know. I'm beginning to become numbed by all of this. If I have to fill out any more paperwork for the school in an hour, I swear I'm gonna explode. I just feel like I've been in crisis mode for the last 3 weeks. I didn't sign up for this.
Maybe it'll calm down a little bit.
Once everybody's locked in their houses and
Yeah.
only allowed to take the dog for a walk or yourself for a walk.
Mm-hmm.
But don't go to a playground because they're closed.
That's
Try
gonna
and socially distance yourself as much as possible.
Yeah.
Have you been on campus at all, Dr. Nichols?
I haven't been on campus since I was going to go in yesterday and run some NMRs, but
Yeah, there's been an unreal amount of people on campus right now. Like not students, but pedestrians, I guess. They're just walking their dogs and it's weird.
well, it's free reign. I mean, people always let their dogs walk on campus so they can just let them crap everywhere and
Hey,
better than their yard.
Yeah.
But people have to get out.
Yeah.
I mean, you're not going to have JCU PD standing at the sidewalk telling people they can't come in.
I sure hope not.
But the buildings are locked down, I think.
Are they?
Yeah, I think so.
Well,
I don't know. Some people, they don't have internet access at home, so they have to do their lectures there. Plus, all this video stuff takes up a hell of a lot of bandwidth.
Mm-hmm.
So, the next 2 weeks, or more are going to be interesting. I don't know when this ends. It better end when it's appropriate for it to end.
Have you heard about these pass-fail classes?
I think the current thinking is we're against pass-fail classes, but it's been thrown out at other universities.
Yeah, I think Kent did it, and there's
Well, it's Kent.
yeah, and Ohio State's talking about it too. But I thought
Well,
Kent was superior.
I mean, I think our biggest concern is if it goes pass-fail, then everybody's interest goes straight down, right? Because you just want to pass. But then the other thing is, what do you do for professional schools? Now, if everybody is doing pass-fail, then the professional schools will have to figure something out. But I think the current thinking right now is that we're not going to do that.
Makes sense.
But you know what? Everything is in flux. This is only week 2.
Yeah, I mean it's just so much change so fast, and how each professor. It's like a lot of the times in class you'll get graded on your participation. You can't really participate now if it's like an asynchronous lecture, so they just send you a bunch of other work to do.
Yeah, I mean, we're trying to make
They do
sure
it
that
more
everybody
from that.
learns what they need to learn.
Yeah.
And there's different ways to do that. So we'll see. I don't know. It's going to be a long haul. Okay.
Thank you.
If you got questions, Piazza, email me, set up I'm sure there'll probably be an NMR group asking questions later.
Yeah.
But let me help you out and put that explanation to one of the problems up.
Okay.
That'll help with one of the problems that's due this week.
Thank you.
There were a few we had some questions on.
Well, whatever you got, I'm
Okay.
going to be here for a while unless I'm out walking.
Okay. Thank you.
All right.
Thank you.
Have a good
Okay,
day.
we'll see ya.
Bye.
Bye.